Hi, is Dr. Mamari, and I'm going to perform experiment 10, part B, which is determining molar mass of unknown liquid using ideal gas law. When we talk about gas laws, there are Boyle's law, Charles law, combined gas law. We have Avogadro's law, and we have combined gas law. We are in this part of the experiment, we are only using the ideal gas law in order to identify molar mass for unknown liquid, which we have to first change it to gas and assume that is going to behave ideally when it's a vapor phase, and use the ideal gas law in order to find the molar mass. So in order to find the molar mass, we need the pressure. So basically, PV equals nRT. So we need the pressure based on the setup that you are going to see in this experiment. When we are going to change the liquid to vapor, the flask is going to have a hole. When we set up the flask, we're going to close it with the aluminum foil. We are going to close it with the aluminum foil, and we make a pinhole there. So it means the container is open to the outside. Because the container is open to environment, pressure inside the flask is going to be equal to pressure outside of the flask. We are going to measure the volume, which is the volume of the gas. The Erlenmeyer flask that is used is a 125 Erlenmeyer flask, but that stops right here. We are going to fill it up all the way and measure what would be the volume of this flask. By filling up with water and measuring how much water is going to hold. So I would follow the procedure for that. So I just want to look at the variables first. R is ideal constant. Constant value for ideal gas laws. The value 0.08205 liter ATM mole Kelvin. What does this unit indicates? So if we are using the pressure, it must be in ATM, volume must be in liter, N must be in moles, and temperature must be in Kelvin. Temperature, how do we measure the temperature? When we set up this for vaporizing when we finish our setup, the flask is going to be inside the boiling water, is going to be there for like 5 minutes at least, or until everything is vaporized. The temperature inside the flask and outside the flask is assumed to be the same. So we are going to measure the temperature of the boiling water and record as the mass of, as the temperature for the temperature for gas. So when we have all these variables, we have the pressure, which we are reading the barometer, and it will be provided to you. Volume we measure experimentally. Temperature we measure experimentally. The value for R is given to us. We can calculate number of moles. If we have number of moles and we have the gas, the mass for the sample gas, then we can calculate the molar mass. So when we find the number of moles, then we are going to use this formula that everybody knows. Number of moles is mass divided by molar mass, and if you rearrange the formula, then number of molar mass is going to be mass of the gas divided by number of moles of the gas, which we are using this formula in order to find the molar mass. First, from ideal gas law, we are going to use these variables and find the value for N, which is number of moles. Then we are going to use equation number 3 in order to find the molar mass, because we measure the mass of the gas. How do we measure the mass of the gas? First, we have the mass of the empty flask. Then we are going to have the mass of the flask plus the vapor. We subtract the values and we get the mass for the gas inside the flask, and we find the molar mass. The setup for the equation is presented on this page of the lab manual, which is the second page of part B. You want to make sure to know the components, what do you need. You see the flask is all the way into the hot water, so we measure the temperature of the hot water as the temperature of the gas. And since it's open to the environment, we measure the atmospheric pressure, and we say it's the same as the gas inside the flask. Now, to follow the procedure, I'm just going to stop sharing this document with you. You have the lab manual that you purchased from Vital Source. You have the ebook for this course, and the purpose of the experiment today is for you to get the data. So by watching the video, you are going to record the values for data. You collect your data so you can complete your data sheet and finish the calculation and turn in to your professor as an assignment. So we're going to start with the procedure for the experiment. And step one, it says to obtain a dry flask, the 125 ml flask, and make sure that there is no cracks and all that. Then we are going to cover it with the piece of aluminum foil. Going to cut piece of aluminum foil. I try to make it small piece of aluminum foil, as long as it covers the top of the flask, because if it's too large, then it's going to go trap more water inside. We have to put a boiling stone in there also. You're adding a boiling chips or boiling stone. We are going to cover it, secure it with a rubber band, and use a pin to make a pinhole, a small pinhole, as long as it's open to the environment. We measure the mass for this setup, everything as the empty or without the vapor. We're going to measure the mass. And in your report, that mass actually goes to the report sheet. Let me see what is designation for it. Well, there is no designation, so it's just the first item that you have there, which is the mass of the flask. So I'm going to record here for you. 91.460, 91.460 gram. That is the mass of flask. Boiling stone, oil, all together, the foil cap, and rubber band. So we have that now. Then we are going to get an unknown sample. We have 3 unknown. I'm going to just choose the first one, unknown A. And with the unknown A, I take 5 milliliters of the unknown and I add to the flask. Then I add to the flask. That's the step 2 of the procedure. The unknown is inside the fume hood, and I'm just going to get the 5 milliliter added and bring it back. The liquid is inside the flask. Going to secure it with the rubber band. So, and I like to fold these aluminum pieces of the aluminum foil up so it doesn't trap the liquid inside. Then we place inside the hot water bath, which I set it up here. Secure it and leave it inside the leaving inside the hot water bath. Wait for the liquid to vaporize. When the liquid vaporizes, it changes to vapor. The excess amount of the vapor is going to escape. At the same time, the air inside the flask also is going to escape and is going to be replaced by the vapor of this unknown liquid, whatever it is. And we will see like some of the vapor coming out of this hole, or we're going to just wait until the liquid is gone. And how do we know the liquid is gone? The boiling stone that I had in the liquid now, it's inside the liquid. When the liquid is gone, then the boiling stone would be dry. Basically, there's no liquid. I'm going to take the camera closer for you to monitor it to see the boiling. Now it is boiling. The boiling flask is right there, and the boiling the boiling stone is inside the liquid. When around the liquid is going to the liquid vaporizes, the boiling stone is going to come out of the liquid. Then I know all the liquid has been vaporized. Then I take it out and follow the procedure to cool it down and do the next step, measure the mass. So I have to wait. For that, I'm going to write something here to help me for later, using the time efficiently. So I need the mass for later on, or my next step. I need the mass of flask, boiling stone, oil cap, rubber band. This after cooling. There's still some liquid there, so I'm going to allow it to cool off with some paper towels. Dry the outside of the flask after I take it out. It's boiling, but this is not gone, it's not. Just bring one piece of paper. Okay, it's completely dry. Take it out. Overheat. Dry the outside of the flask. Let it cool down. Cool down. It's better to reach to room temperature before we measure the mass. We measure the mass of all the objects while they are at room temperature. Okay, the temperature is okay. 91.904 grams, and that is the mass. Okay, for the sample. So we are done with the first trial, just measuring the mass. We need to now for the second trial, we just need 4 milliliter of the sample. So the mass for the empty flask is going to stay the same for the second trial. So I'm going to write this again. Let's see what I can do here. Let's see. For second try. Second. So now that we have the mass, we are going to get more of the sample and perform the same experiment one more time for 2 trials. So in case there is one positive error in one trial, we get negative error on the other one. They cancel each other. It's better to take average of the 2. I have to carefully open this because I'm not measuring the mass again. I'm using the same combination that I had before, so it has to be the same foil and the same rubber band that I'm using for the second try. I'm getting the 4 milliliter of the sample to bring and continue. You probably have some leftover already in there. You place the foil cap. You're going to secure it with the rubber band again. Place in hot water bath. Okay. starts boiling. I just keep track of the boiling stone. See where it is. I look at that point. When the boiling stone comes out of the liquid, that means the liquid is dry. It's easier for me to recognize it. Okay. Completely dry. Inside all vaporized. So we dry the outside of the flask because we don't want the moisture or droplets of water adds extra mass to the flask. Wait until is cool down to room temperature. So let it cool down to room temperature. I see, like sometimes I see condensation coming out, but it's okay to have condensation because the vapor, when it's in high temperature inside the beaker, is in gas phase, but when we take it out, it condenses, it comes to liquid. So it's okay to have some condensation and the liquid around the stone at this point because the stones are not moving around anymore because it gets some condensation. That condensation is all right, and it's supposed to be as long as it was dry before. So if it's dry before, now there's like a little bit of a drop in there. Okay. To measure the mass after is cooled down to room temperature. I have to wait at least is as cold as the last one. I don't want to measure the mass while it's hot. And if you see this balance, the mass is changing because it's cooling down. So when the mass stays constant, I can record the mass. That's another way to recognize it, that it's still hot. Okay. Second one, 91.8. Eight, 2, 0. So we have the mass. Temperature needs to be measured. So we're going to measure the temperature. So just want to make sure the water bath temperature is 95 degrees Celsius. First try and second try. First and second try. Okay. Now we need the pressure, barometric pressure. It's 756 millimeter mercury. The barometer is in the other room, in the prep room. I just have to go look for you and come back. So 756 millimeter mercury for first and second trial with optimize. Volume of the flask, we have to use the same flask. We use the same flask. Fill it up because different flasks, they carry different volume. Okay. It says 125, but it's not 125 as I said, because here also holds the gas. So we have to fill it up all the way. And transfer into graduate cylinder. Try not to spill anything. That's 100. $159.5. 159.5 milliliter. Volume of the flask. First and second trial. They are the same. The only thing that was different for first and second trial is the mass of the vapor, which you are going to calculate. Just make sure that you are going to record those numbers in proper place in the table. So when you are doing your calculation, you have all the information. Some of them, they are the same, like the volume didn't change, volume of the flask doesn't change. It's the same barometric pressure because it's the room pressure is the same for both 1 and 2. And then when you have your numbers, then you answer your questions and do calculation, also additional questions on the other side of the data sheet. Okay, it wasn't too bad. It was a fast kind of experiment, but usually we do this experiment at the same time as we are doing experiment 11, which is the colligative properties. Since I titled this, I'm going to start a new video for experiment 11. Since I titled this just for experiment 10, I'm going to stop the recording at this point. Just make sure you record your data and read the experiment. Thank you.